somebody took one look at your mower, shook their head, and told you it's time to drop $1,000 on a new one. Do me a favor and don't believe them yet. Give me the next few minutes, because most of the time that machine isn't finished. It's choking on something small, something so cheap to fix, it's almost insulting. I've got 7 ways to bring a tired mower roaring back from the edge, and I'm going to level with you right now before we touch a single bolt. 2 of these cross a line the manufacturer drew on purpose. One of them has a little plastic cap bolted right over it for no reason other than to keep your screwdriver out. The other steps straight into territory the EPA would rather you left alone. That's not me hyping you up. There is a real physical part on your engine, built for the sole job of stopping you from making the fix I'm about to hand you. The other 5? Dead simple, completely above board, and every one of them is the difference between a mower that limps and a mower that pulls like the day it came off the lot. Stick with me to the end, because after this, you are never going to look at a dead machine the same way again. Fix. Number 1 is the mower that's starving, starting fine, then losing power as fuel flow falls behind demand. It stumbles under throttle. Maybe it dies in tall grass and makes you yank it back to life. 9 times out of 10, the first word out of somebody's mouth is carburetor. And that's how people end up buying a whole replacement carb or handing over a diagnostic fee for a problem that lives 2 inches upstream. Before the carburetor ever enters the conversation, look at the fuel filter and the line feeding it. That little inline filter is the cheapest part on the entire fuel system. And when it clogs, it strangles the flow just enough to starve the engine right when it's asking for more fuel, under load, under throttle, exactly when you notice it. A restricted filter can imitate almost every symptom a failing carburetor throws at you, from a rough idle to a flat no start. The fix is about as cheap as small engine work gets. Pinch off the line, pull the old filter, and check which way the arrow points before you seat the new one. These are directional, and a filter installed backward will fight you. While it's open, run fresh fuel through the line and make sure it's flowing clean, not dribbling out thick and varnished from a season of sitting. One thing I want you to not do, because it floats around online and it's bad advice: don't blast carburetor cleaner backward through the fuel system to reverse flush it. Pushing solvent the wrong direction through the line and pump can chew up the rubber components you're trying to save. Replace the filter, clear the line properly, done. And I'll be honest with you about the limits here. If your carburetor is genuinely gummed solid from old fuel, a fresh filter alone won't save it. But it's the first thing you rule out. It costs a couple of bucks, and it takes 5 minutes. You check the cheap part before you condemn the expensive one, always. Fix number 2 is the mower that's drowning. Now flip that problem completely around. Fix 1 was an engine gasping for fuel. This one's the opposite, an engine drowning in it. The tell is unmistakable once you know it. You get a strong raw gas smell, hard starting, a rough and loading up idle, sluggish throttle response, sometimes fuel weeping where it shouldn't be. And once again, the internet's first instinct is to condemn the carburetor and order a new one. In most of these cases, you don't need a new carburetor. You need to fix the float level inside the one you've got. Here's what's happening in there. The float controls how much fuel sits in the carburetor bowl, the same way the float in a toilet tank controls the water level. Set too high, the bowl overfills, fuel floods past where it should stop, and the engine runs fat and wet. That's your raw gas smell and your hard, flooded start. Set too low, the opposite happens. The bowl runs shy, the The mixture goes lean, and you fight a stubborn cold, start and a stumble right off idle. The part people miss is that this almost never calls for a new carburetor at all. It's an adjustment. You drop the bowl, find the small metal tab that sets where the float rides, and bend it a hair to raise or lower the level back into spec. That's it. Fix number 3 is the surge nobody can tune out. The first problem on this list where the wrong fix can create an even bigger headache. Here's the first of the 2 I promised you. This is the mower that won't hold a steady idle. It hunts up and down on its own. Rev up, drop off, rev up, drop off, like it can't decide how fast it wants to run. People chase this thing for hours. They clean the carburetor, swap the plug, blow out the air filter, and it still surges. And then they find the mixture screw and realize there's a plastic cap sitting right on top of it, blocking the adjustment. That cap isn't there by accident, and it isn't there to help you. On a lot of newer small engines, the manufacturer installs a plastic limiter cap over the mixture screw, specifically to restrict how far you can turn it. And the reason is emissions compliance. These engines get tuned lean at the factory to burn cleaner, and that deliberately lean setting is a big part of why they hunt and surge in the first place. The cap exists to keep you from rigidening the mixture back out of that lean zone. In other words, the fix for your surging engine is the exact thing that cap was designed to stop you from doing. That's why this one's on the list. You can pop the cap off with a small pick or a flat screwdriver and get full range of the mixture screw back. But I'm going to be square with you about what that means. That cap is emissions hardware, and removing it to retune the mixture can affect the emissions compliance of a newer machine. Nobody's kicking in your garage door over it, but I'm not going to pretend the part isn't there for a regulatory reason, because it is. Now, before you go reaching for that pick, do the boring checks first, because a surge has cheaper causes too. A dirty air filter throws the mixture off on its own. So does a partially clogged carburetor, and no amount of screw turning fixes a carb that actually needs cleaning. Rule those out first. If the engine's clean and it's still hunting, then you're looking at a factory lean setting, and that's when the mixture screw earns its keep. Fix number 4 is take a hard starting engine everybody misdiagnoses. This is the sleeper on the whole list. I'd bet most people watching have never once checked it, and it's one of the most common real reasons an older engine starts hard and feels gutless. It's valve lash, the tiny air gap between the valve stem and the rocker arm when the valve's closed. As an engine racks up hours, that clearance drifts out of spec, and when it does, a few things go wrong at once. You lose compression. The engine gets harder to start. It idles rough and feels down on power. And here's the part that connects the dots for a lot of no-start headaches. The compression release mechanism on the camshaft, the little feature that bleeds off cylinder pressure so the engine spins over easily, depends on the valve lash being correct to do its job. When the lash is off, that release can't work right, and you get an engine that cranks like it's fighting you and won't fire. People stare at that and assume the whole thing's shot. Bringing it back to spec is a real adjustment with real payoff. You pull the valve cover, and with the engine cold, you rotate it so the piston's coming up on the compression stroke. On a lot of Briggs engines, you actually set the piston a 1/4 inch past top dead center specifically, so the compression release bump on the cam isn't holding a valve open while you measure. Then you slide a feeler gauge into the gap and set it so the blade drags with just a little resistance. Now the number matters, and this is where I need you to not just copy a figure off the screen. A typical Briggs overhead valve engine runs somewhere around 3 to 5 thousandths on the intake and 5 to 7 thousandths on the exhaust. But that's a ballpark, not gospel. It changes by engine. Some of the bigger V-twins spec closer to 10 and 12 thousandths. The clearance for your engine is tied to its exact model number, which is stamped right into the metal, usually on the blower housing or a plate near the muffler. Fix number 5 is the "it's smoking, it's done" engine, the scary-looking problem that convinces owners the engine is finished when the real fix is often much simpler. If you've ever seen oil soaking into your air filter or smoke wisping out of the breather, you already know the gut punch that comes with it. That's the picture everybody's been trained to read as a death sentence. Worn piston rings, blow by, the engine eating itself. It's the exact symptom that sends a running mower to the curb. So before you write it off, check the crankcase breather first, because a bad breather fakes this whole thing. Inside the valve cover on these engines is a small breather with a reed or flapper valve. Its job is to vent the pressure that naturally builds in the crankcase while the engine runs, and to keep oil from going where it shouldn't. When that little valve stops sealing, gummed up, stuck, worn, the crankcase can't vent properly. Pressure builds, and that pressure shoves oil straight up through the breather and into the carburetor and air filter. On the outside, that looks exactly like an engine blowing oil past tired rings. On the inside, it's a couple dollar part that failed. The fix, in a lot of cases, is replacing the breather, not tearing the engine down. There are plenty of engines out there that got scrapped or rebuilt for a problem a new breather would have solved in 10 minutes. But I'm going to keep you honest here, because this is where a bad video would oversell it. Oil in the air filter can also be the real thing, genuinely worn rings, actual blow-by. Fix number 6 is the sealed for life lie, the maintenance myth that's quietly shortening the life of countless machines. If your riding mower or zero-turn has gotten weak in the drive, sluggish off the line, slow to build speed, whining or straining under load, worse when it's hot, the drivetrain fluid in your hydrostatic transaxle is very likely worn out, and when you go to change it, your owner's manual will very likely tell you that you can't. Sealed for life, no drain plug, no service interval. Buy a new one when it dies. Here's the thing that gets me about that. The company that built the Transaxle disagrees with the company that sold it to you. Tough Torque, one of the two big names that manufactures these units, publishes the fluid change procedure right on their own site and confirms that plenty of their Transaxles are serviceable with a filter and a fill you can actually get to. Meanwhile, the Mower brand slaps "sealed" on the same unit and calls it a day. That's not a conspiracy theory off a forum. That's the manufacturer's own documentation contradicting the label on your machine. The fluid itself is real, spec'd, and available. Hydro Gear and Parker units typically run a 20W50. It's common enough that OEMs sell it straight off the shelf as their hydrostatic fluid. Tough Torque units use their own Tough Tech synthetic drive fluid, and Tough Torque specifically warns you not to dump automatic transmission fluid in there thinking it's close enough. It isn't. Use what the unit calls for. I'll set expectations honestly, because this is the one real project on the list. The block off a Saturday afternoon job, not a 5-minute fix. On a lot of these, you're pulling the Transaxle off the machine, getting to the filter and the fill, flipping it to drain the old fluid out, and refilling with the right stuff. When you first fire it back up, don't panic if it does nothing for a moment. There's air in the system that needs to purge before the drive comes back. give it a minute, and normal forward and reverse returns. 2 honest caveats. First, a lot of these is not all of these. Some units genuinely aren't built to be serviced easily. A few families have no drain at all, and some are just plain obsoleted. Check what's actually under your machine before you commit. Second, this is not beginner territory. It takes time, a little muscle, and patience. But look at what's on the table. A worn-out hydro that a fluid and filter refresh brings back to life costs you around $50 in parts and an afternoon. A replacement Transaxle runs into the hundreds. A used one is a few hundred, a new one more. And swapping in a different unit isn't even plug and play, because Tough Torque points out they're built to specific OEM specs, and substituting one is its own headache. Fix number 7 is chasing more power. The upgrade everyone talks about and the risk almost nobody mentions. Here's the second fix the manufacturer doesn't want you making, and I want to handle it differently than everything before it, because this is the only one on the list that can genuinely wreck your engine if you get it wrong. The idea is simple, and it's why people are tempted. Your engine's top speed is held in check by the governor, a spring-loaded system that limits maximum RPM. Add tension to that governor spring, and the engine will rev higher, which means more blade tip speed and more grunt. Online, plenty of folks treat this like free horsepower just sitting there waiting to be unlocked. I'm not going to sell it to you that way, because it isn't free, and pretending otherwise would be doing you a disservice. When you raise the RPM ceiling, you're pushing the engine past the speed it was engineered and balanced to run at. Overspeed a small engine, and the failures aren't gentle. We're talking thrown connecting rods, damaged pistons, and complete engine failure. And this isn't just an "it'll wear out sooner" caution. An engine spinning far past its limit can throw parts hard enough to be a genuine safety hazard. The flywheel magnet can shatter and send pieces flying. That's not a scare tactic. That's what over-revving one of these actually does. On top of the mechanical risk, this one will void your warranty. No argument from the manufacturer. And since you're changing how the engine runs, you're back in that same emissions territory I flagged at the very start. This is the other place the regulators would rather you left alone. So why is it even on the list? Because it's real. It works when it's done carefully within limits, and a lot of people do it. So you deserve the honest version instead of the hype version. If you go near that spring, tiny adjustments, understand you're spending engine life for RPM, and know that this is the one fix here where a mistake is measured in a blown engine, not a wasted afternoon. Out of all 7, this is the only one I'd tell you to think twice about before you touch it. So step back and look at what just happened to that dying mower. You unstarved it, you undrowned it. You killed the surge, brought back the compression it lost, and figured out whether that smoke was a $2 breather or the real thing. You put fresh life into a drivetrain you were told was sealed shut forever. And if you've got the stomach for it, you know exactly what the last one costs before you ever reach for it. Not one of those needed a shop. Not one needed a garage full of specialty tools. What it needed was somebody willing to check the cheap part before writing the big check, and to know which fixes the manufacturer would rather you never found. That's the whole difference between the person standing in a dealership staring at the price of a new machine and the person who knows their old ones got years left in it. So tell me down in the comments, which of these had you reaching for your toolbox, and which one have you already been doing for years? And be straight with me on the last one. Are you the type who touched that governor spring? Or is that a line you're not crossing? Let's hear it.